we are given a trapezium ABCD such that AB and CD are parallel to one another, and CD is 2 times of AB, and then what else do we have? A point E here such that it divides the whole line AC in a ratio 4:3. And what else do we have? Another point F here such that if you join this EF, you will get a line which is parallel to both AB and CD. What else do we have? The diagonal BD cuts this at a point G. And what do we have to prove? That 7 times EF is 11 times AB. And how are we going to do that? Usually, how do we solve such questions? We take a triangle with EF as its side, another triangle with AB as its side, and we solve this question. That is how we do it, by proving the similarity, right? But then if you look here, EF, it is a fairly long size, and it is quite impossible to consider a triangle with the whole of EF as its side. So what we will do is break down this part, consider it as FG and GE. So let us consider 2 different sets of triangle, one which will involve FG, another which will involve GE, and then we will add both the results. That will give us EF. That is our plan of action. That is what we are going to do. So shall we start? We will start from the side where the information is given, where the numbers are given. We will consider this side where we can use these numbers. So we have to prove the similarity of 2 pairs of triangles. The first pair should include GE. So what is the first thing that comes to your mind? This triangle here BGE, this small triangle BGE, and this huge triangle BDC. The minute you see that, what do you notice? A common angle B. BDC and BGE, it is in the name itself. First, a common angle. Can you get more angles? These 2 sides are parallel, which means what? The alternate interior angles here. Again, another set of alternate interior angles here. So what do you have? 2 similar triangles. When you write the names of the triangles, be very careful. Equal angles should come in corresponding places. B is equal to B. G is equal to D, and this E, where you see E here, there should be C. This is how your 2 similar triangles look like. So once we get the similarity, what follows? Ratio of the corresponding sides is same. So once you write down their corresponding sides, this is how your set of equal ratios looks like. So here, which one do we know about? We know about this side. What is this side? What is EB? It is 4. What is BC? It is this whole side, which is 7. And what do we need to connect? We need the only which has GE. This is true, but still we do not need this. We are not going to break our head with unnecessary information. So what we have is GE by DC is what? It is 4 by 7. So what we have got is a result which involves GE. What we need is a result which involves FG. But before we go to that, consider the triangle that we were dealing with just now. The BCD, this huge triangle BCD, consider that GE is parallel to one of its sides DC, which means what does BPT say? It cuts the other 2 sides in equal ratio. That means BG is to GD and BE is to EC are going to be same. Their ratio is going to be same. That means this is also going to be cut in the same ratio 4:3. Now jump to this side. Consider this triangle ADB. What happens there? ADB also, the same story is repeated, but now it is with FG. you have a triangle ADB, and you have a line inside that triangle which is parallel to one of its sides. Then what will that line do? It will cut the other two sides in equal ratio. That means if this is 4:3, this will also be 4:3. Keep it in mind. We will go on to the next part. Now we need a result which involves FG. How do we do that? Consider this big triangle DAB and this small triangle here which is DFG. Can you prove its similarity? One look at it, you know there is a common angle which is what? D here. So you have got one angle. You just have to find another one set of ratio or angle. What will be the easier one to do? Finding the angles. Why is that? Because we have two parallel lines, which means what? Alternate interior angles. This angle G here and B here are same. F here and A here are same, which means applying the AA criterion, these two triangles are similar. Once they are similar, what follows? Their corresponding sides, the ratio of their corresponding sides here will be same. But then, do we know the value of any particular one? Just one is enough. The others will just follow. Look at this, the one which has DF and DA. DF is just 3. DA is the whole one, which is what? 7. And which is the other ratio that we are looking for? The one which involves FG. You do not need the third one, so I will remove it. So what do we have? We have FG by AB is equal to 3/7. So from the first equation, you get GE is equal to what? Cross multiply, bring DC to this side, but we will make everything in the terms of AB because we already have an AB here, right? And remember, we have still not used the information that DC is equal to 2AB. We have not used it. And this is where we are going to use it. Instead of DC, write 2AB again. FG, what do you do? Cross multiply, bring AB to that side. Now add both of these equations. And now GE plus FG is what? It is the whole of EF. And what happens in this side? Take AB out, it is common, and then you get such an equation. And so when we cross multiply, we get such a result, which was exactly what we were looking for. So that is all for today. You take care. Assalamu alaikum.